recording here, just so no one misses my joke. Just kidding. All right, let's see, where'd I put it? Okay, Walter took his wife Ethel to the state fair every year. And every time he would say to her, Ethel, you know I'd love to go for a ride on that helicopter. But Ethel would always reply, I know that, Walter, but that helicopter ride is $50. And $50 is $50. Finally, after many, many years of going to the fair, they went again. And Walter said to Ethel, you know, I'm 87 years old now. If I don't ride that helicopter this year, I may never get another chance. Once again, Ethel replied, Walter, you know that helicopter is $50 and $50 is $50. But this time, after many years of hearing them, the helicopter pilot went over to them and said, listen, folks, I'll make a deal with you. I'll take both of you for a ride if you can both stay quiet for the entire ride and not say a word, and I won't charge you. But if you say just one word, it's $50. Walter and Ethel looked at each other and agreed, and up they went into the helicopter. The pilot performed all kinds of fancy moves and stunts and tricks, but not a word was said by either Walter or Ethel. The pilot did his death-defying tricks over and over again, went by beautiful scenery, but there was not so much as one word said. When they finally landed, the pilot turned to Walter and said, wow, I've got to hand it to you. I did everything I could to get you to scream or shout out, but you didn't. I'm really impressed. Walter replied, well, to be honest, I almost said something when Ethel fell out, but, you know, $50 is $50. All right, and for our spiritual thought today, so I had an interesting conversation with my daughter this morning. So Hannah is 6 years old. She turned 6 last month, and so she's in kindergarten this year. And ever since winter break, she's been like, Dad, I don't want to go to school today. And I'll be like, sorry, kid, you got to go to school today. It kind of reminded me of my childhood and adulthood. But then she was like, well, so this is like several days that she's asked me this over the last like 2 weeks. But then today she was like, Daddy, am I going to go to school for the rest of my life? And I kind of chuckled. I'm like, well, if you take your life right now and double that, it's that amount of time until you like graduate high school. And then you'll go to like a bunch more school after that, depending on what you want to do for work and stuff. And she seemed a little put out by my answer. I feel bad. Sometimes I'm like the mean dad who's just blatantly honest and not very sensitive. But we started talking about it, you know, and about like why we have school. And, you know, sometimes I don't want to go to work and people don't want to go to school and like it just happens, but we do it anyways. And it reminded me of a scripture in Mosiah chapter 24. Now in this chapter, Alma and his people are all in bondage. And so much so that even if they try to pray, they'll be put to death. And so in verse 10, it says this, and it came to pass that so great were their afflictions that they began to cry mightily to God. And then in verse 12, and Alma and his people did not raise their voices to the Lord their God, but did pour out their hearts to him. And he did know the thoughts of their hearts. And it came to pass that the voice of the Lord came to them in their afflictions, saying, lift up your heads and be of good comfort. For I know of the covenant which you have made unto me, and I will covenant with my people and deliver them out of bondage. And then 2 verses later, came to pass that the burdens which were laid upon Alma and his brethren were made light. Yea, the Lord did strengthen them that they could bear up their burdens with ease, and they did submit cheerfully and with patience to all the will of the Lord. So this is really interesting to me because it's not like the Lord forgot about their covenant and then all of a sudden remembered when they started praying, you know, like he knew exactly what was going to happen. He knew what was happening. He knew of the covenant that he had with them, but he didn't say a word until they started pouring their hearts out to him in prayer. And I think about our lives and how frequently we have challenges and afflictions, whether we get physically sick or we're lonely or we're homesick or we're sick of school or we're just busy. We have like stresses, financial, familial, whatever. Like there is like an endless list of challenges that we will have in our lives and do have very frequently in our lives. But these people, you know, they were like in like a life and death situation, and still the Lord didn't say anything until they started praying. And the second they started praying, he blessed them with comfort. And then he ended up blessing them in such a way in that near future that they could be joyful and bear their burdens with ease. And I'm amazed by this because the Lord loves us perfectly. And I feel like so often he is just waiting to bless us. but he needs us to act in faith first. And that's just part of this life. That's part of the reasons why we have afflictions. That's part of the reasons why things are hard, so that we can learn how to trust him, learn how to come unto him. But I know that as we do so, if we just try our best to come unto him, he will bless us in more ways than we can imagine. And oftentimes it's hard to remember that. And sometimes when we're neck deep in affliction, it's like, oh my heavens, I need help. And that's the first place we go. And then afterwards we're like, I should probably pray when I don't have challenges too. But I'm amazed at how much he loves us. I'm amazed at how much he helps us. And I'm amazed that he lets us have all these challenges, and somehow they work out for our good. And somehow things work out. And so as we continue in this semester, I just encourage you guys to remember him always. And, when things seem hard and when things seem easy, pour out your hearts to him, and he will bless you with his spirit and everything. All right, Matthew, go ahead with our prayer.
Our dear Heavenly Father, we're so grateful for this wonderful opportunity that we have to be able to meet together today. Heavenly Father, we love thee. We're grateful for thy spirit, thy gospel, and the comfort that it brings to our daily lives. We're grateful for Brother Birch and for the preparation he's made to be able to teach us these programming concepts. Heavenly Father, we're grateful for the chance to learn and be here at BYU Idaho. Bless us with thy spirit, and we say these things in the name of Jesus Christ. Amen.
Thank you, Matt. All right, well, you guys, I have good news. Hopefully we made it through the hardest week of the semester, simply because you had 2 weeks of material to cover in 4 days. So congrats. With that said, before we move on, do you guys have any questions about anything from last week? Lessons 1 and 2. Anything that you saw that didn't make sense? Anything you worked on that you need help with? Anything? Well, sweet. Well, if you guys remember questions later on, I'm totally fine with you interrupting me. But if there aren't any questions, then let's go ahead and move on. So let me pull up our slides here for the day. And let me share my screen. All right, can you guys see my screen? Okay, so one of the basic functions of a computer, something that all computers can do and is a huge part of what makes a computer, is the ability it has to store and save data. Think about how pointless our computers would be if you download a program and you couldn't save it anywhere, okay? Or you write a file and you can't save it anywhere. So our computers are all capable of saving data. And when we write programs in Python, we are also capable of saving data in what we call variables. So today, and for the first half of this week, we're going to focus our learning on variables and expressions. So everything to do this lesson, this will be pretty normal for every one of these lessons, okay? You'll have a lesson 3 checkpoint, team activity, proof assignment, and your lesson 3 reading. Okay, and the links to all of these are here in the slides that you guys have access to. All right, so working with numbers. So last week we talked a little bit about the difference between different types of data in Python and in really in any programming language. But we talked about strings. If I just have some text or anything in quotation marks, that is a string. But a lot of things that I want to be able to do in a program, I can't do with just strings. I need to be able to use numbers. Now, it's interesting because if I pull up my text editor here, I'm just going to make a new file. Let's see. I'm just going to say it's called temp.py. Now, in here, if I say age equals 31, okay? Now, is 31 a number or a string?
It's a string. Because
it's a string. It's kind of cool, but it is a string. And we know that because of the quotation marks. Okay. And so if I decided that I wanted to do something with this, okay, eventually you guys are going to learn how to be like, oh, if age is less than 50, okay, just like you would in like a math class. Okay. I could make a statement like this in Python and say, hey, if age is less than 50, I want to do something. Well, if I try to do this with a string like this, it won't work because Python doesn't recognize 31 as the value of 31 over 0. It recognizes 31 as like the alphanumerical characters in our language, 3-1. Okay, and so I can't do any type of math with this 31. I can't do any comparisons. And there's a lot of other things that I can't do with it. So if I wanted this to actually be a number, I would write it just like this. Instead of with the quotation marks, I would just say 31, just like that. Okay, and then it's a number and I can actually work with it. Okay, well in here, we have a couple of different types of numbers. We have ints and floats. Anybody know the difference?
Float's going to be able to carry a decimal.
Yeah, great. So this number right here, is it a float or an integer?
Integer.
It's an integer. Anytime I have a whole number, it's an integer. If it was 31.0, yes, that's a whole number, but because there's a decimal there, even with a 0 after it, it is a float. Integers are incapable of having decimal points. And then any decimal after that, they're all floats. Okay.
I have a quick question about that.
Yeah, go ahead, Larissa.
Sorry if it's kind of dumb, but why can't I just use float always? Just because it might just be a float, or like combined or added with something else, might just be a float. Does that make sense?
That is the least dumb question I've ever heard. Okay, that is an excellent question. Does anyone know the answer to that question? Why do we even have ints then? Why won't we just always use floats?
Because the space all adds up.
Wow, Elijah, good job. Yes. So our computers are fantastic, okay? And they're really, really powerful, way more powerful than they were when Python was invented a number of years ago. With that said, we want our programs to function as quickly as possible. Now, generally, when I have a program, it's going to be more than 3 lines of code, like you see right here. Think about the number of lines of code that it would take to run a program like Zoom, for example. You're talking like hundreds of thousands, millions of lines of code that's running simultaneously to be able to run this program and help us be able to communicate, okay? And so with that, the amount of space that variables take up in memory really, really matters. Because I don't know if you guys have ever had like an old computer that didn't have very much space on the hard drive and it just like got more and more full with time. You notice that they're really, really slow. And they kind of just get slower and slower to the point where you're like, I need a new computer. This is not working. Well, programs are the same way. Okay. The more of your computer's resources that you use, when I say computer's resources, I'm talking about like RAM. Okay. Because anytime I'm storing variables or data in variables like this 31 or this, or, this is being stored in RAM on my computer once I run it. That's where it's going to be saved temporarily. The more of that space, more of that RAM that I use up, the slower my program will run. Now, in this class, it's not going to be a big deal because we're not going to write programs that are millions of lines of code. But it is good practice to get into the habit of using ints. So if I ask someone for their age, they're usually not going to tell me 31.0283452. They're usually just going to tell me 31, okay, or 30 or whatever. But basically, anytime I'm asking someone for something that is going to be a whole number, I'll use an int. So be like, oh, how many people were in class today? Well, right now there's 19 of us. There's no decimal there, so I'll use an int for that. Okay, well, how much of your bagel did you eat this morning? Maybe you ate 60%, so I'll use a float for that. Okay, and so anytime you can use an int, you want to use an int just to get into the habit of having well-performing programs. But just know that it won't really make too much of a difference in this class. So, but Larissa, that was an awesome question. Thank you.
Got it. Thanks.
Yeah. Okay. Any other questions, you guys? Ian, yeah.
Do you need to do anything to make it an int versus a float? Or is it just like, okay, it has a decimal, so now it's a float? Or do you need to put brackets or something? Like, does that make sense?
It does make sense. Have you programmed in another language before?
No, I was just curious.
Okay. Yeah, no, you don't. You don't. A lot of programming language actually, you'll have to specify, be like, oh, this is going to be a float. And you actually type in the name of the data type that you're going to use. Or if I wanted to declare a string, I'd say string name equals Nathan or something. But I'd have to say that. Python's really nice because you don't have to say that. Instead, you just name a variable and it dynamically decides what it's going to be. So it looks at this and it's like, oh, that's a float. If it saw this as 31, it's a number with no decimal, so it'll be an int. If it saw this with anything inside of quotation marks, then it'll be a string. Okay, and same thing with other data types that we haven't talked about yet. But great question, Ian.
I have a question.
Yeah, go ahead, Brandon.
So do we also have like, not Boolean, sorry, doubles, or is it just integer and floats?
Integer and float in Python.
Okay, I'm just wondering.
Yeah, so Brandon brings up another one of those things that you'll find in other programming languages. There are all sorts of numbers. Honestly, in my opinion, it's a little bit extreme. But especially some older programming languages, you'll look at them, they have like int, float, double, long, extra long, super double, frame, like there's like all these data types that is meant to have well-performing applications, you know. So if I need a number that has 20 decimals, I'll use a float. If I need a number that has 60 decimals, I'll use I don't even know what they are, but they have different data types depending on how much precision you need in your numbers. So, but no, in Python, it's just int and float. So, good question. Okay, any other question? Any other questions? Sweet, let's keep going. All right, these two functions right here. Remember last week we talked about functions a little bit, okay? We talked about when Python tells a computer to do something or has a command or a function. We looked at some of these when I said, well, you know, I'll just like this, print age. Now I could run this. Let me just, I'm gonna open this up in my terminal. Bring this window up a little bit and I'll say pi temp.py, and you can see it successfully printed 31, okay? So I just told my computer to print up age, this variable, and the way we did that was with this Python function. Now I know that this is a function because I have a word, in this case print, and then a parenthesis right next to it, no space, no other character. I just have word, and right after the T, the next character is that opening parenthesis. Anytime I have that, so another one we saw is this, input. Please enter an age. Okay, these are both functions. And I know they're both functions because I have a word in both cases, and the next character is an opening parenthesis. All right, now sometimes you'll have functions that don't have anything in the parentheses. It's just a function that runs, and that's fine, it's still a function. Okay, but anytime I have a word and an opening parenthesis, that's a function. Now, the reason why I bring that up is because of these two functions in Python. These are built into Python just like print and input, and they allow me to convert a piece of data into something else that I want it to be. So let's say, for example, that I said print age. We know that age is a string, right? And then right here, I'm going to say int age. Okay, now int is that function that we just looked at. And I'm actually going to print this again. Okay, so I have a bunch of functions running right here. I have int, and this will convert my number 31 from a string into an integer. And then print is going to print onto the console whatever came out of that int function. Okay, so I'm going to hit Control S to save. Come back down here, hit up arrow and enter. Okay, 31 and 31. They look exactly the same, right? When we print up strings in Python, they don't show the quotation marks. Okay, but watch this. I'm going to come down in here and I'm going to say print age, but this time I'm going to say float. Okay, so I need my closing parentheses for both of those. So I have age, I have my float function to turn it into a float number, and then I'll print it. And then I'll do the same thing, but I'll turn it into an integer. Okay, watch what happens now. Okay, notice first we have a string, even though it doesn't have quotation marks. It only has quotation marks when we see it in the code. Okay, when it gets printed, it doesn't print the quotation marks. The floating point number does have a decimal. Okay, we turn that into a float, and you can see the decimal right there. Even though it's 0.0, it's still a float. And then we turned it back into, and then we turned it into an int, and then we don't have a decimal there anymore. Okay, so working with numbers, anytime I want to turn something into a number, I can. I just have to use float or int. Okay. Now, what would happen if I did something like this? Any guesses on what would happen?
Would it turn it into the? Would it give back the space where it saves?
Brandon, what programming language have you worked with before?
C++.
Yeah, I can tell. No, it wouldn't. It wouldn't C++, but not here. Okay, that's a really good guess. If I run this, this gives me an error. It says value error could not convert string to float, George. Okay, so that's kind of nice because usually in C++, if I'm trying to convert a string into a float, I don't really care about the location of memory. There could be a case where I do, but if I did, then I would just ask for the location of memory, not try to convert it to a float to get it. But here in Python, it'll just give me an error. And I'll be like, you can't turn a word into a number, dude, that's not gonna work. And that's what happens. It just broke my program. Notice it didn't print anything. It could have printed, I guess it did print age once, which was George. And then as soon as it ran this float, this age, trying to convert it to a float, it threw an error and it didn't run the rest of my program. Okay, so this float function and this int function only work if a string is legitimately a number, even though it's a string. Okay. All right. Get numbers from the user. So if I wanted to get a number from the user, do you guys remember this function? What does it do?
It gives a cursor so that the user can put in information.
Awesome. Okay. Does it do anything else?
You can also use it to print like a question, like, please add an adjective here.
Nice. So if I have a print function and I say, this is awesome, I could technically put this exact same thing into my input and print that as well. And up to a point, they will do the exact same thing, but input takes it a step further and adds a cursor, like Gavin says, a place where the user can type something. And so I'm going to say, please enter your age. All right. And so now I have a print statement. The input will also print something, but it will allow the user to give me something back. All right. So I'm going to run this. This is awesome. Please enter your age, 54, and my program's done. We got 54 back right here. We can't tell because we didn't do anything with it. But what input does, input is a function that will return a value. The value that it returns is whatever the user types in. So I typed in 54, which means that 54 was returned to this point in my code. And if I had just said like user age equals input, it would have worked. Okay. And I would actually have that age stored in a variable, which is one of the key things that a computer can do. I can take input and save it into a variable. Now, let's go ahead and save this. And now I'm just going to say print user age. Okay, and I'm going to say 54. And you can see we successfully saved that 54 into the variable user age. Because on the third line in my print statement, I just said print user age. And we successfully printed 54. Now, does anybody know how to have Python tell you what data type a variable is? Python show variable type. Okay, how to determine a Python variable's type. All right. Whoa, there's a type function? That's awesome. There's a built-in type function. And so look, he said I equals 123 and then type I. Okay, so let's try that. Let's see what happens. We might have to print that if we want to actually see it. So right here, I'm going to say type user age, right? So type, I guess, is another function. We have a word and then an opening parenthesis. And we're passing in a piece of data to say, hey, I want to see the type of, in this case, user age. All right, let's see what happens if we just run it. 54, it didn't do anything. So let's go ahead and print this because we want to print whatever came back from that. Let's save, come back over here, up arrow, enter, 54. Look at that. That's new. Class string. So the data type of this variable that the user entered is a string. Now, every single time you use input, no matter what the user types in, I just typed in a number, 54. That is a very valid number, and it's a string. No matter what you type in, it will always be a string for input. That is what input returns. That is what it will always return no matter what. So if I wanted this to be a number, how could I turn this into a number instead of a string?
You do the int
Yeah,
user age.
yeah. So back here at our slides, we have int and float to turn strings into numbers. So I'm just going to come over here, and this is what my number is going to end up being, right? Where this whole input thing is. So I'm just going to jump right here, and I'm going to say int end line closing parenthesis. Okay, so I have, if I delete this, I have my int function, and inside of this function, I'm putting the input function, and inside of that, we're saying, hey, please enter a number. Okay, now let's see what happens. Hit my up arrow, type in 54, just like I did before, and now look, we have an int. We have a number that we can work with. We can do comparisons with it. We can do math with it. We could say, hey, next year you're going to be 55 years old instead of 54. You know, it is now a valid number and not just a couple of characters that resemble a number to us.
So I have a question.
Yeah, please.
So me just trying to do it with you, how come I can't put int user age on, like, let's say we add another row and I put it on row 3 after the input? How come that function doesn't end up working? And it still says that data is a string.
So, do you want to share your screen real quick?
Sure. Let me go back to where I was.
And let me make sure that you can share.
I cannot yet.
Okay, you should be able to now.
Okay. Can you see?
Yep.
Would it be because you're trying to change the data type of the variable that's already been initialized?
Ooh, okay, I see what's going on.
That's what I was trying to do right there.
Okay, so something really important to notice. So int will convert user age into an integer, right? Type will show that. Did you just answer your own question by typing in line 2 right there? Gavin?
What? No, I have no idea.
Okay.
If I do syntax error, okay, I'm getting errors now.
You're good. End of line 4. Just hit backspace on that last character.
Oh, there we go.
Oh, hang on. I think there's another character there now. There you go.
Because this still shows it's a string.
Interesting. So what we'd have to do, so int will turn that into an integer for us to use it, but it won't actually change the variable itself. So for example, let's say I say x is equal to 20, and then I say x plus 30. Okay, well, x plus 30 is going to be 50, but I didn't assign that 50 to anything. Okay, so let me share my screen real quick, and I'll show you that example. Okay, so right here, I say x equals 20, and then x plus 30. All right, if I was going to print this right here, we would see 50, right? Because x plus 20 or x plus 30 is 50. But so watch this. Let me just print this, and then I'll say print x. And then I'm going to comment all of this out and run it. Okay, so check this out. We have 50, but then x is still 20. Why is x still 20? Just think.
The data point itself is 20.
Yeah, I didn't change the variable. I did some math with it, but I didn't change the variable itself. So if I wanted x to actually be 50, I would have to say x equals x plus 30. Okay, because then that'll give me that 50, Okay, I still have this x plus 30, but I didn't assign it anywhere. It's great if I just want to print out that 50, it's just fine. But if I ever want to use that 50 again, I have to assign it back to x. So the x changes. Okay, now I bring up this example because it's the exact same thing with you. If I want to print up, let's say I have age equals 50, and then I say int age. Okay, now this line of code will use the number 50, not a string 50, it'll use the number 50. But if I go down here and I print age, that's back to a string. Or if I print the type of age, it'll show string because I didn't actually change it. If I wanted to change the variable itself, I would have to say age equals int age, because then I'm taking that value and it's like, okay, I just converted this to a number. Let's put it back into the variable age. Okay, or right here, okay, now I have x plus 30. Let's go ahead and reassign all of that to x. And so I have to use this assignment operator, our equals sign, to be able to change data that's stored in my variables. Okay, does that help, Gavin? Okay, awesome, great question. All right, any other questions, you guys?
Yeah, so I have a question with what you on lines 11 and 12.
Yeah.
When you set the age to 50, you set it as a string on line 11, and then line 12, you have the same variable, and you're setting it to an int now. Does that work in Python?
Yes. Yep.
Okay, so you're able to change the data type as you go.
Yes, but like I said, only if it works. Okay, remember when we put George in here? We had that big old error and my Python program just stopped. But as long as it's a valid number, then I can go ahead and change the type. And you'll notice in other programming languages too, you can do the exact same thing. It's called casting variables. So if I have a number that's in a string, I can do the same thing. It's really nice because Python makes it really easy. It's like, oh, I want to turn it into an int, just stick it into an int function. I want to turn it into a float, stick it into a float function. And so it's really simple in Python. But yes, that is very legal to change the data type. Now, there are some pieces of data that you can't change. They're called immutable. We'll talk about those later in the semester. But ints and strings and floats, you can change them and even change their types if applicable. Ian, did you have a question?
I did. For like simplicity's sake, would you be able to, for example, age equals 50, could you do it like age 1 equals int age so that you have a separate variable so it keeps things, I guess in my mind, keeps everything making sense?
Yeah, for sure. If you wanted to do that, you could just rename the variable. Usually if I have the same variable with just a different data type, I might even put that into the variable name. So I might say like age number or age num, or up here, say age string or something like that, just so that I could look at them and be like, hey, the only difference between these is the data type. But no, if you wanted to do that, you could totally do that. Great question. Okay. Any other questions? Sweet, let's keep going. These are awesome questions, you guys. Get numbers from user. So we just looked at that. We have an input, which is where a user can type in anything, and then we can just convert that to an int. And then when we use the equal sign to assign it to a variable, we'll get a number in that variable. Why convert? We already talked about this. You can't do math or numeric comparisons with strings. And what math? Yes, you guys, we are going to have to do math in this class. Now, it's not very intense, okay? I usually say that I like math, but in all honesty, I like elementary school math, okay? I'm pretty good with numbers, like addition, subtraction, multiplication, but you get me into like calculus and stuff, and I'm just like, nope, I'm done. I've no desire to get this deep into math. I'll stick to the real world. Not that calculus isn't in the real world. I don't want to offend anyone. But anyways, we will have to do math in this class, but really it's like middle school, elementary school, you know, it's like, you know, back in the day. So order of operations, I don't know if you guys remember hearing that back in the day, but it does apply in programming. No matter what language you are in, there is a level of precedence or order of operations that will be followed. So this is not the order, just so you know. I'm just throwing out all the different types of math that we're going to be looking at in Python. So we have addition with a plus sign. That's nice and simple. 3 plus 4 equals 7. Subtraction, 3 minus 4 equals -1, just as you'd expect. Multiplication, 3 times 4 equals 12. Division, okay, so for division, I don't even know how to find like the horizontal bar with the dots on top and bottom on my keyboard, or even how to type it. I'd have to like look in the characters in Microsoft Word or something to find it. But so in programming languages, I've never seen it used any other way. We just use the /. That's how we do division in programming. So 15 divided by 4, we get 3.75. Division always returns a float. Okay, even if I said 10 divided by 2, it would return 5.0. Okay, divide and drop the remainder. Okay, so 2 / right together. They do division, but it forces the number to round down to a whole number. So let's think about why that might matter. Let's say we're on Zoom and I wanted to set up breakout rooms for everyone, and we had an odd number of people. I said, okay, I want groups of 4. You know, we have 18 people in here right now. That means 4 of us, or 4 groups, would successfully land into 4 groups. Okay, or we'd successfully have 4 groups of 4 people. Now we would use what's called floor division. That's what this is. 2 /, the divide and drop the remainder. That is floor division, which forces it to round down. So if I said 18 divided by 4, I would regularly get 4.5. But if I do floor division, it would force it down to 4, which would let me know that I need 4 groups of 4, and then I'd have to figure out that second number on my own. But there are a lot of cases where you want to find that lowest number. Okay, if I said, how many people are we going to be able to feed for the next year if we can't go to Walmart? Okay, well, I'd have to like divide up rations, and I want a whole number. I don't want to say, oh, I could feed like 4.5 of us. You know, I want a whole number and then figure out what to do with the remainder. Speaking of remainder, we have our modulus. Okay, the modulus gives us that remainder. Okay, so floor division and the modulus together are pretty powerful. So if I had 25 divided by 7, regularly we'd get like 3.45-ish, somewhere in there. But with modulus, it says, okay, 7 goes into 21 3 times with 4 left over. So modulus returns that 4, that leftover value. Okay. Questions on these, you guys? Okay. And then we have exponents. Okay, this is a really nice way to do exponents because I can never figure out how to do those like tiny like subscript numbers. And so exponents, we just use 2 asterisks. Okay, and so I'd say 3 double asterisk 4 is 81, because 3 to the 4th power, 3, 9, 24, 81 is 81. Okay. Order of operations. This is the order, and it shouldn't be too much of a shock to you. It's really similar to algebra. Parentheses are always first. So if I have addition that has to take place before multiplication, I put it in parentheses because that will always happen first. Exponents happen next. Then we have multiplication, division, floor division, and modulus. These all have the same level of precedence. So if I have a single expression that has a multiplication and a division symbol in it, what do I do? Any guesses?
You would use parentheses to specify which one you want to go first or second.
You certainly could. Yeah, and a lot of people do that just to make things really clear. So let's test this out. I'm going to say print 5 times 2 divided by 3. Okay. Now, if I just leave it like this is valid Python. Okay. We would just go left to right. Okay. And I could test that. I'd be like, okay, 5 times 2 is 10 divided by 3 to give me like 3.3, right? But if it was the other way around, 2 divided by 3, I don't even know what that is. It's got to be like a negative number or something. But then times 5 would be very different. So I'm just gonna hit my up arrow here, and you can see we do have 3.3. Okay. But let's say I wanted this division to happen first. All I have to do, like Ian said, parentheses. Now, That's a cool little trick I could show you guys in VS Code. If I select something and hold shift and hit my double quotes, or if I hold shift and hit my parenthesis, it'll just put one on both sides, which is really nice. But now I'm forcing this math to happen first, and then whatever results from that, we'll multiply it by 5, and that's what we'll print. So let's see what happens. Okay, wow, we get the same thing. That's interesting. I guess that kind of makes sense. But anyways, so that is a little bit on how that'll work. So anytime something shares the same level of precedence, it'll just go left to right. And then addition and subtraction also have the same level of precedence. And so we just do left to right. But again, similar to what we just saw with this, it won't really matter if I say print 5 plus 2 minus 3. Okay, that would give me the exact same thing as if I said print 5 minus 3 plus 2. They'll give me the exact same thing. It's just how math works. And then our last one is our equal sign to assign a value. So thankfully this is last because we can do all of the math that we need to before we assign a value to a variable, or in this case, like what we just did before we print a variable. Questions on order of operations?
Brother Birch, how come it doesn't need, or how does the computer know to not do or continue the decimals like a repeating decimal?
That's a really good question. Anyone know the answer to that question?
Can't you limit it?
What was that, Brandon?
Can't you limit it, the decimals?
Yeah, so the computer by default, or Python, will not change what it's outputting. All right, it has a fixed number of decimals that it'll do that you can kind of see here. But if I wanted to change that, I could just say, hey, I only want to see the first 2 decimals or something. And we'll look at some of that in a little bit. Okay, but there are ways that I could format this to say, hey, I want to see 1 decimal or 5 decimals, or I know it's going to be money, so I want to see 2. And we'll look at that in a little bit. All right, so here's an activity for you guys. We are going to do the first 5 of these together, okay? And then I'll open up breakout rooms and you guys will do the rest, okay? So let me put this, I'll put this over here. That works out nicely. Oh, that didn't. There we go. Okay, so let's just start at the top. 3 plus 4, what are we going to output? What do you guys think?
7.
7. Yeah, it better do 7, right? Otherwise Python's broken. Okay, sweet. Let's do our next one. Print 3 plus 4 times 6. What's it going to output?
27.
Who said 27?
Me.
That was awesome. Yeah, I think so. Because the multiplication will happen first, right? So we'd have 4 times 6, which is 24, plus 3 would be 27. But let's test it. So we do get 27. Otherwise, it would have been 18. We would have said 12. Oh, no, it would have been a lot more than 18. 12 times 6. I actually don't know what that is anymore. Yeah, anyways. Okay, so let's look at the next one. Print 3 plus 4 times 6 divided by 3. So I'm just going to copy that. Oh, yeah, go ahead. Oh, someone have a question? Okay, cool. So I'm going to hit Control C. Notice I don't have anything selected. I hit Control C, which will copy the entire line. And when I say entire line, I mean this right there. The whole line with the line break above it. So I just hit copy, Control C, and then I'll just hit Control V, and it just pasted the whole line right there, which is really nice. And then I'll just say divided by 3. Again, order of operations, what are we going to do first? What's the first step in this?
Multiply.
Yeah, 4 times 6. Okay, so we get 24, then what?
Divided by 3.
Perfect. So we take 24 divided by 3, we get 8. And so we should get 11 here. Let's test it out. Sweet. Okay, why is this 11.0 and not 11?
Because there was division, so I made a float.
Yep, division always returns a float. Even though 8.0 was a whole number, it'll always return a float. Okay, again, Control C, Control V to copy that line. And let's see what we're changing. All right, we have 1 asterisk asterisk 3 plus 4 times 6 divided by 3. Okay, what happens first?
Plus 3.
Yeah, yep, 3 plus 4. Our parentheses happen first. So we get 7, then what?
1 to the power 7.
Which is
1.
1. Sweet. Okay, so we have 1 times 6 divided by 3. What happens next?
1 times 6.
Perfect. Yeah, at this point, we'll just go left to right. So I'll have 6 and then divided by 3. We should get 2.0 because we had division in there. Okay.
Here's
All right.
my question.
Yeah, go ahead.
When does it, how can we tell when the exponent ends? Because if I ended up using my scientific calculator, I could put all of that in my exponent's position.
Yeah, that's a great question. So if I wanted all of this to be in there, I would have to go like this. I just select this whole thing and hold shift and hit my parenthesis. Okay, now that's saying, hey, I have 1 to the exponent of all of this. Okay, it'll just take whatever's next to it. So if I had like 3 and then plus, I would just say, okay, I have 1 to the 3rd power. And then after that's done, I'll add. Okay, but whatever's next to it, that is what will be the exponent. Great question. All right, last one as a group. 1 to the power of 3 plus 4 times 6 divided by 3 modulus 2. Okay, what do we do first? Again, parentheses, and then exponent. We already know that this is 1. 1 times 6 is 6. And these 3, again, have the same level of precedence. We'll just go left to right. So we have 6 divided by 3 is 2. Modulus 2, 2 goes into 2 evenly with nothing left over. So it should just be 0. Okay, and there we go.